Hi, in this video we will derive the equation for rectangle. Okay, so I considered a rectangle of base width b. Okay, let me take width of the rectangle as b, and let me assume d as depth of the rectangle. Okay, let me mark the centroid for this. Let g be the centroid of the rectangle, and x is the axis passing through the centroid of the rectangle. Okay, for derivation purpose I will consider an elemental strip, of width b1, width b only, same width as width of the rectangle, width b, thickness dy, and at a perpendicular distance y from centroidal axis. Okay, for derivation purpose I have considered an elemental strip of width b, thickness dy, and at a perpendicular distance y from centroid of the rectangle. Okay, now area of elemental strip is equal to area of elemental strip is equal to, let me call it as dA, is equal to, it is width it is a rectangle of sides b and dy, correct? So b into dy, okay. Now what we will do, we will find the moment of inertia of this elemental strip about the x-axis. Moment of inertia of elemental strip about x-axis is equal to Ixx is equal to, moment of inertia is area into distance square, area of the elemental strip is dA into distance is y, dA into y square. Therefore moment of inertia of whole area about x-axis is equal to Ixx is equal to, now we have the equation for moment of elemental strip about the x-axis. To get the moment of inertia of the whole area, you have to integrate this equation. Okay, integration limits from, see, this is very important step. The distance is d by 2, distance of the centroidal axis from the base of the rectangle is d by 2, and above the x-axis also it is d by 2. Okay, so here limits will be from minus d by 2 to plus d by 2. Okay, you should not take limits from 0 to d. Okay, you should not take limits from 0 to d, because you have to apply the limits with reference to the axis about which you have measured the moment of inertia. You have measured moment of inertia about x-axis, no? With respect to this x-axis only, you have to apply the limits. Below the x-axis it is minus d by 2, and above the x-axis it is plus d by 2. So the limits is from minus d by 2 to plus d by 2. Okay, dA into y square, dA is b into dy, substitute. Therefore limits from minus d by 2 to plus d by 2, dA is b into dy into y square. B is constant, take it outside the integration, minus d by 2 plus d by 2 y square into dy. Now integrate with respect to y. B into y cube by 3 limits from minus d by 2 to plus d by 2. Okay, so 3 is constant, take it outside the bracket. B by 3, in the bracket it is y cube, limits from minus d by 2 to plus d by 2. Now apply the limits. B by 3 into d by 2 whole cube means it is d cube divided by 8 minus d by 2 whole cube, correct. B by 3, let me write this as d by 2 whole cube only. In the next step we will write it as d cube by 8, d by 2 whole cube. Okay, it is d cube by 8 minus, okay, minus d cube by minus d by 2 whole cube means it is minus d cube by 8. Okay, therefore b by 3 d cube by 8 minus into minus plus d cube by 8. Okay, therefore b by 3 the LCM is 8 only, d cube plus d cube, it is 2 d cube divided by 8, 2 ones are 2 fours are. So the final expression for Ixx is equal to bd cube divided by 12. Okay, this is the expression for moment of inertia about x-axis. Similarly, by considering a vertical strip at a distance y from central at a distance x from central y-axis, you will get the expression for Iyy. Similarly, okay, if you derive the equation for Iyy by considering the vertical strip, you will get the expression as dv cube by 12. No need to derive this expression in detail. You can just derive the equation for Ixx, then you just write similarly Iyy is equal to db cube by 12. Okay, so this completes the derivation of the rectangle, derivation of the moment of inertia of the rectangle. Thank you.